Hello everybody. Today we are going to solve question number 11. Consider the reaction below. 2 silver gets oxidized to form silver oxide solid. Calculate Gibbs free energy change at room temperature 298 Kelvin. B. Does silver get oxidized at room temperature? And please calculate the equilibrium oxygen pressure at room temperature. C. Calculate the temperature when delta GT is 0. And let's look at delta G 298 Kelvin is delta H 298 Kelvin minus 298 Kelvin times delta S 298 Kelvin. Step by step we are going to calculate based on this reaction. Let's start off with entropy change at room temperature. As silver oxide 298 Kelvin minus 2 times entropy silver at 298 Kelvin plus half times entropy oxygen gas 298 Kelvin, and delta S 298 Kelvin is equal to, we know this value 121.3 minus 3 times 42.6 joule per Kelvin plus 0.5, this is the coefficient half, 0.5 times 205 joule per mole Kelvin, and delta S is about minus 66.45 joule per mole Kelvin, and the entropy decreases upon this reaction. Entropy decreases. Why? Because half mole gas reacted with solid silver, which form silver oxide, which is also solid, and gas converted into solid, and this is the reason why entropy value decreases. Is it enough? No, this is just indication. And let's look at delta H value. 298 value. And for this H silver oxide at 298 Kelvin minus 3 times enthalpy value of silver plus half times enthalpy value of oxygen gas 298 Kelvin. And now we know that this corresponds to 0 because this is pure substance, pure enthalpy of pure substance at 1 atm at 298 Kelvin is equal to 0. And delta H 298 Kelvin enthalpy of silver oxide at 298 Kelvin, which is minus 31,100 joule per mole. And this is just the indication. If the reaction goes to right, this kind of energy is obtained. This kind of energy, this amount of energy is manufactured, is produced based on this reaction. But in order for us to decide if the reaction goes to right or left, we need to look at our driving force. 8 Kelvin. Delta H 298 times 298 times delta S value at 298 Kelvin. Delta G value is 298 is about 11,283 joule per mole, which is about 11.3 kilojoule per mole. And if this value is negative, you know, this negative value, the reaction proceeds spontaneously. It's spontaneous reaction and goes to right, because this is lower than 0 value. However, it becomes non-spontaneous after some point, which means when the temperature increases. As you see here, when we increase the temperature, stops and delta G value becomes 0, and we call it equilibrium point. After this equilibrium point, delta G value becomes greater than 0 and becomes non-spontaneous reaction. Silver stops being oxidized. Instead of silver oxide converted into silver plus oxygen gas. Let's look at delta G. T is 0. That's T. We don't know this T. Delta HT minus T times delta ST. This doesn't change with temperature much, so we can take this one minus 30,100 joule, and this is about 66.45 joule per mole Kelvin, and this is 0. And T would be delta HT divided by delta ST, which is 31,166.5. This is about 468 Kelvin. And this is the reaction. At this temperature, the reaction stops. Either it goes to right or form silver metal. And this is equilibrium point. After this temperature on, say 500 Kelvin, and silver oxide, which is formed upon the reaction with oxygen, transform into silver metal plus oxygen gas at elevated temperature. And in order for us to calculate equilibrium oxygen pressure, this is delta G, this is general delta G, and this is delta G standard, and this RT and KP, and this is the deviation of standard situation, standard state. And this belongs to 0, this corresponds to 0, and delta G is equal to RT and KP. What is KP? And this is KP is activity of silver oxide, activity of silver times activity of oxygen, square root of. Instead of activity of oxygen, we take pressure of oxygen because this is gas. And delta G minus 831 more times 298 Kelvin, because we are interested in room temperature. We are going to calculate the oxygen pressure for silver to form silver oxide. Silver converted into silver oxide based on oxygen pressure. When we change the oxygen pressure, either we form silver or silver oxide depending on oxygen pressure. Okay, I will explain later. Activity of silver oxide is 1. Activity of silver is 1 times square root of pressure of oxygen. ln Kp is ln 1 over PO2, and from this one, PO2 is 1.10 times 10 to minus 4 atm, which means that normally oxygen pressure is 0.21 atm. So this value PO1 greater than this one. So silver is oxidized at atmospheric conditions because normally we have 0.21 atm, and this is the equilibrium pressure, which means at this pressure is enough to form silver oxide. If we have dark silver or oxidized silver, is it possible for us to remove this silver oxide? Is it possible if we put this sample into furnace at, for example, 300 Celsius, which is 573 Kelvin, and silver oxide is converted into silver? We carry out this experiment in the laboratory, and we know that this conversion takes place. However, normally silver contains 92.5 silver bracelet, ring, pendant, etc. contain 92.5% silver and 7.5% copper. When we put this sample, this ring into furnace, it gets more darker and darker. Why? Because copper oxidized to form copper oxide. So you don't need to carry out this kind of experiment uh, at homes, because we cannot get shiny silver. If you have 99.99% silver, and this reaction works very well. What I am saying is oxidized silver is subjected to elevated temperature in a furnace at home, for example. It get rid of its tarnish or oxidized layer to form shiny elemental silver based on these thermodynamic calculations. Thank you very much.